When benzene or substituted benzene is treated with an acid chloride in the presence of anhydrous aluminium chloride, it gives the corresponding ketone. Boiling points of aldehydes and ketones are lower than those of alcohols of similar molecular masses. The electrophilicity of the carbonyl group in the ketones decreases due to the presence of two alkyl groups. Acetaldehyde treated with methyl alcohol, it will form hemiacetal. That hemiacetal treated with dry HCl, it will form acetal. Hello everyone, this is Harshita Bhavasar from Vidhyaashram PU College Temple of Excellence. Now I am going to start session 2 from the chapter Aldehydes, Ketones and Carboxylic Acids. In the previous session we have discussed about introduction part of aldehydes and ketones, nomenclature of aldehydes and ketones, nature of carbonyl group and preparation of those carbonyl group are aldehydes and ketones. Now we will discuss about preparation of ketones as well as its physical and chemical properties. From acyl chlorides, how the ketones will be prepared. Acyl chlorides are treated with dialkyl cadmium, which is obtained by the reaction of cadmium chloride with Grignard reagent. We know that what is Grignard reagent? RMgX. That Grignard reagent should treated with cadmium chloride, then dialkyl cadmium will be formed. Okay, that dialkyl cadmium should be treated with acyl chloride to form ketones. Okay, here dialkyl cadmium is very much needed. First it has to be prepared, then it has to be treated with acyl chloride. Here we will see one example. Ethyl magnesium bromide will be treated with cadmium chloride. In ether it will form diethyl cadmium. Okay, that diethyl cadmium will be treated with benzoyl chloride, which is acyl. In the place of acyl chloride, it will form ethyl phenyl ketone. This is how ketone will be prepared or formed by acyl chlorides. Next we will see preparation of ketone from nitrile. Treatment of nitrile with Grignard reagent followed by hydrolysis gives ketones. This is nitrile RCN treated with Grignard reagent. In the presence of ether, it will give some intermediate. That intermediate will be hydrolyzed. Then after hydrolysis, ketone will be formed. Okay. For example, here ethyl nitrile will be treated with phenyl magnesium bromide in the presence of ether. It will form one of the ketone. It is an intermediate. On hydrolysis, it will form propophenone or 1-phenyl propane. This is how from nitrile ketone will be formed. Next, from Friedel-Crafts reaction, this is one of the important reaction for the exam purpose. When benzene or substituted benzene is treated with an acid chloride in the presence of anhydrous aluminium chloride, it gives the corresponding ketone. When benzene or any substituted benzene reacted with acyl chloride in the presence of anhydrous aluminium chloride in ether, it will give aromatic ketone. For example, when benzene is treated with acetyl chloride in the presence of anhydrous aluminium chloride, it will give acetophenone. It will form corresponding ketone, means here acetyl we have used, here acetophenone will be formed. The corresponding ketone will be formed as a product. Next, physical properties of ketone. Due to the polarity of carbonyl compounds, the physical properties like melting point, boiling point or any other physical properties will be dependent. So here methanol is in gaseous state at room temperature. Ethanol is in liquid state or that is a volatile liquid. Other aldehydes and ketones are liquid or solid at room temperature. Except methanol and ethanol, like lower membranes of aldehydes, other aldehydes or ketones are liquid or solid at room temperature. Usually boiling points of aldehydes and ketones are higher than those of hydrocarbons and ethers of comparable molecular masses. The boiling point of aldehydes and ketones are higher than ethers as well as hydrocarbon due to its molecular masses. Reason: there are weak molecular association in aldehydes and ketones. In aldehydes and ketones, the weak association of molecules can be seen. Due to that reason, boiling point will be high, arising out of dipole-dipole interactions, and it will lead to the dipole-dipole interaction, and there is a weak molecular association in aldehydes and ketones. That's why boiling point of aldehydes and ketones are higher than the hydrocarbons and ether. Boiling points of aldehydes and ketones are lower than those of alcohols of similar molecular masses. The boiling point of aldehydes is lower than boiling point of alcohols because there is an absence of intermolecular hydrogen bonding. Due to the absence of intermolecular hydrogen bonding, what is hydrogen bonding? One of the molecule of aldehyde should be reacted with the hydrogen of water. So that or any of the hydrogen, that relationship or that bonding is not there. So boiling point of aldehydes and ketones are lower than the boiling point of alcohols. Lower membranes of aldehydes and ketones are miscible with water in all the proportions. Lower membranes of aldehydes and ketones, okay, those are miscible. Miscible means it will be dissolved in water. In both are liquid state. Lower membrane of aldehydes also in liquid state and also water is also in liquid state. So we'll call as a term miscible when liquid is dissolved in liquid. Here lower membranes of aldehydes and ketones are miscible in water because there is a presence of hydrogen bonds, okay, with water. See here, this is a overall aldehyde and it will be formation of hydrogen bond with hydrogen of water molecule. So here you can observe the hydrogen bond. That's why lower membranes of aldehydes and ketones will dissolve or will miscible in water in all the proportions. Solubility of aldehydes and ketones decreases rapidly on increasing in the length of alkyl chain. When the alkyl chain is getting to increase in the aldehyde or ketone, it will start gradually decreasing in solubility. Okay, obviously the alkyl chain, whenever it is getting more, its molecular mass will also getting more. That's why its solubility will getting decreased. All aldehydes and ketones are fairly soluble in organic solvents such as ether, methanol, etc. Ether and methanol and any other solvents are those solvents of laboratory which will be in which aldehydes and ketones will be fairly soluble, not as greatly. Lower aldehydes have sharp pungent odors. As the size of aldehydes increases, the odor becomes less pungent and more fragrant. Lower aldehydes have sharp pungent odors. Pungent odors, you know, it is not that much pleasant odor. Lower aldehydes will be having sharp pungent odor, but as the number of chain increases or the membrane, as the member of aldehydes will get increased or size will get increased in aldehydes, the odor becomes less pungent and become more fragrant. Pungent and fragrant are completely opposite terms and completely opposite properties. In the lower aldehydes, lower member of aldehydes, it will be showing pungent smell. In the higher member of aldehydes, it will be more fragrant. Okay. So these are the physical properties of aldehydes and ketones. Next we'll see the chemical properties. In the chemical properties, first one we'll see nucleophilic addition reaction. Here nucleophile get attacked, but how it will attack and what is the product we'll see. Nucleophile attacks the carbonyl group perpendicular to the plane of sp2 hybridized orbital of carbonyl group. Here nucleophile will attack to the carbonyl group but in a perpendicular to the plane. We know that carbonyl group is on the plane. To the perpendicular of that carbonyl group, that nucleophile will be added. This is sp2. Here nucleophile will get added and it is planar in region. And it will form an intermediate called tetrahedral intermediate. Okay. Next, on the hybridization of carbon, sp2 hybridization will become sp3 hybridization. Here double bond is present, so it will be in sp2 hybridized form. After the nucleophile is added perpendicular to the carbonyl group, it will form tetrahedral intermediate. At the end, after hybridization, addition product will be formed and it will be sp3 hybridized product. A tetrahedral alkoxide is formed as intermediate which captures proton and gives electrically neutral product. This is a tetrahedral alkoxide product which undergoes protonation, okay, or proton will be added. Later it will give neutral, electrically neutral product. This is how nucleophilic addition reaction can be seen. Next, reactivity. Ketones are less reactive than aldehydes due to steric and electronic effect. Ketones are less reactive comparative to aldehydes because of two effects, that is steric effect and electronic effect. We have to understand what is steric effect. The presence of two bulky substituents in ketones hinders the approach of nucleophile to carbonyl group. Ketone means two alkyl or two aryl members can be seen. If these two are become bulky in nature, obviously it will hinder the capture of nucleophile towards the carbonyl. It will hinders the nucleophile attack. So, ketones will be less reactive than aldehydes. Okay. Next, electronic effect. The electrophilicity of the carbonyl group in the ketones decreases due to the presence of two alkyl groups. It may be two alkyl or two aryl, we know that. So, if because of these two alkyl groups, the electrophilicity means the acceptance of any electrons or any group will be less. Due to electrophilicity means the acceptance of any electrons, we'll call it as electrophilicity. It will become, that property will become less due to the presence of two alkyl groups. Hence, aldehydes are more reactive than ketones. One steric hindrance, that is steric effect. Another one electronic effect. Electrophilicity will be decreased. Due to these two reasons, ketones are less reactive than aldehydes. Next, addition of hydrogen cyanide to aldehyde or ketone, that is HCN to aldehyde or ketone. In the first step, cyanide ion attacks to carbon of the carbonyl group to form alkoxide ion. In the second step, protonation of the alkoxide oxygen creates the cyanohydrin product. Here HCN, it will be hydrolyzed to form cyanide and water. From HCN, how cyanide will be formed? That cyanide will attack to the carbon of carbonyl group. Later it will form tetrahedral intermediate. That tetrahedral intermediate, after protonation, it will form alkoxide, and that alkoxide oxygen will create the cyanohydrin formation. Okay. Once again, from the HCN, after hydrolysis, it will form cyanide. That cyanide will attack the carbon of carbonyl group and it will form tetrahedral intermediate. That tetrahedral intermediate, after protonation, it will create cyanohydrin product. This is how the addition of hydrogen cyanide to aldehyde or ketone will be formed. Next, addition of sodium hydrogen sulfide. Saturated solution of sodium bisulfite in water when mixed with aldehydes or lower membranes of ketones, it will form crystalline bisulfite addition compounds. When this sodium bisulfite or sodium hydrogen sulfide treated with aldehyde or ketone, which is a carbonyl group containing product, it will form an intermediate, and when the proton transfer has been done, bisulfite addition compound will form. That addition compound will be in crystalline in nature. Example, this is acetaldehyde, which is a aldehyde. It is treated with sodium bisulfite. This is a intermediate, and after the proton transfer, acetaldehyde sodium bisulfite compound will form. Next, addition of alcohols. Aldehydes react with alcohols in the presence of dry HCl gas to form acetals. Aldehydes react with alcohols in the presence of dry HCl to give acetals. Acetals are geminal alkoxy alkenes in which two alkoxy group are present on the terminal carbon atoms. Geminal and vicinal you know already. Acetals are geminal alkoxy alkenes in which two alkoxy group are present on the terminal carbon. This is aldehyde treated with alcohol. It will form unstable hemiacetal intermediate. Later, in the presence of again alcohol and dry HCl, that hemiacetal will form acetal group. Two alkoxy group will be present on the terminal of carbon. Geminal acetal, geminal alkoxy alkane. Geminal means for the same carbon, groups will be attached, same groups will be attached, functional groups. So here you can see. Once again, aldehyde when react with alcohol, acetals will be formed in the presence of dry HCl. Before that, it will form an unstable intermediate called hemiacetal. That hemiacetal, when treated with dry HCl, it will form acetal. Acetal are nothing but geminal alkoxy alkanes in which two alkoxy groups are attached for the terminal carbon. Okay, that is how acetals will be formed from alcohols. Example, acetaldehyde treated with methyl alcohol, it will form hemiacetal. That hemiacetal treated with dry HCl, it will form acetal. For in the presence of R, we have used CH3 here. Here ROH also CH3 and it will form acetals or semi-acetal. Okay. Ketones do not readily react with monohydric alcohols. However, they combine with diols to give ketones. Ketones will not react readily with monohydric alcohols. They will combine with diols to give ketones. Okay. Ketone reacted with ethylene glycol, which is a diol. Okay. Treated with dry HCl, ethylene glycol, ketones will form here. Once again, ketone is treated with ethylene glycol, which is a diol, to give ketones. This is about the preparation of ketones as well as the physical and chemical properties of ketones. Some of the chemical properties are still there regarding ketones. We'll see in the next coming session. In the next session, condensation reactions with derivatives of ammonia, Clemmensen reduction, Wolff-Kishner reduction, test to distinguish about aldehydes and ketones. These are the concepts which we'll discuss in the next session. I hope you have understood completely what I have taught in this session. We'll meet in the coming session. Thank you.